All right, so welcome to our video lesson for Unit 1, Lesson 5, Characteristics of Absolute Value Functions. And I'm really tired this afternoon, so let's hope that I can do this smoothly the first time through and not have to re-record big chunks of it. So without further ado, let's get into the lesson. So there are 5 characteristics of absolute value functions that we're going to cover in this lesson. Now on this slide, they're going to kind of just come up in a big list. You don't need to write them down. They should be in your notes. And then we're going to look at each one in more detail so you can write down what the 5 characteristics are at the same time that you're writing down the definitions and the examples. If you've got the notes outlined from class, then you can just fill that in as we go through the lesson. So the first characteristic is the vertex. And I actually can't see a preview of the next slide when I'm recording this, so I don't know if there's a definition coming up. No. Okay, great. Second one is something called the axis of symmetry, and I actually abbreviate that a lot, AOS. So when you see that like on the board or written on the homework or the test, it says AOS. What that is axis of symmetry, and that's just me trying to abbreviate it, make it a little bit shorter. Where the graph increases or decreases. So you might want to think about what those words mean. So what does it mean for something to increase? What does it mean for something to decrease? And then as we go through that, what we want to be homing in on is what attribute of the graph is it that's increasing or decreasing. That is where it goes up and where it goes down as you look on the graph from left to right. So I'm not 100% sure how the camera is recording this. For me, left to right, I would be moving my hand this way. I just don't know if the camera is going to flip that around. So for you, it might look like I'm going right to left. But yeah, as you trace the graph going from left to right, when we get to that, I'll use the laser pointer. And it's just whether or not the graph is going up or going down. Where the graph is positive or negative. And I would say, honestly, the biggest mistake students make with this is confusing 3 and 4. So increasing and decreasing with positive and negative. And you can kind of see where those words might be related to each other. So increasing or positive, we think of kind of maybe moving in the same direction. Decreasing and negative seem like they would be going together. So as we go through that, make sure that you're paying attention to the definitions. Because positive and negative has to do with where the graph is above or below the x-axis. So one of them has to do with whether the graph is going up or going down, and the other one has to do with whether it's above or below the x-axis. So it could be above the x-axis but heading down. So that would mean it's positive, but it is decreasing. It could be below the x-axis but heading up or going up. So that would make it negative but increasing. And then lastly, something called the end behavior. And there's different ways that we could denote that. So we're going to work through on the next several slides, like what all these things are. And the end behavior, it's whether the direction that the graph is pointing. So if you like picture like little arrows on the graph, like is the graph going up or is it going down at the ends of the function? So you think like, okay, which direction is the arrow pointing? Not left or right. The graphs are, if their functions are always going to be heading left and right also. So we're really focused on whether they are up or down. Okay, so the vertex. So the first question we have there is what is the vertex? So the vertex is the point at the bottom or top of the graph. If you think back to geometry, the vertex of an angle is where two rays meet. And so what we have here is we have a ray with an end point, and the ray is going this direction, like up and to the left. And then we have a ray over here that is going up to the right, and the vertex would be the shared endpoint of the rays. So the definition of the vertex for an absolute value function is consistent with geometry. Now, when we get into like the next unit, we'll talk about the vertex of a parabola, and then you're not dealing with rays anymore, but the principle would still be the same. So we might think of it as the point at the bottom or the point at the top. Now make sure when you're writing the coordinates of the point that you are stating both the x and the y coordinate. So whenever we're talking about points, we're talking about a location on the coordinate plane. And so you want to make sure you reference that point by both its x coordinate and its y coordinate. So actually, I'll wait for a second. So I want you to consider what the vertex of this particular absolute value function is. and then I'll go ahead and fill it in. Okay. So the vertex for this, the x coordinate would be 4 and the y coordinate would be -1. And we'd be looking at that point right there. Okay. That's the vertex of the parabola. Again, most students don't have a problem with this. It's just sometimes just stating just the x coordinate or just the y coordinate. Now the axis of symmetry, and I mentioned earlier the axis of symmetry, I will often abbreviate that AOS for axis of symmetry. So I wanted to start with this, like with a quick discussion of vertical lines. Vertical lines are not functions. So in Algebra 2, we really focus our discussion on things called functions, and vertical lines are not functions, meaning that they don't pass the vertical line test. More specifically, you've got the points like stacked over each other, which means that for every x coordinate, you might have more than one y coordinate. And a function, for every x coordinate, there is at most one y coordinate. A vertical line actually has an infinite number of y coordinates to go with the x coordinate. So they are not functions. Most of the time when we think of lines, we think of this. We think of y equals mx plus b. We might think like a horizontal line. If the slope is 0, the equation would be y equals 4. Well, with a vertical line, the form is going to be x equals instead of y equals. And again, that has to do with the fact that it's not a function. So if you were going to sketch the graph of x equals 4, there's actually 2 ways you could answer that if you don't have any context. One way you might answer that is to just look at like a regular old number line. So 1, 2, 3, 4, and you might say, okay, x equals 4 is just the point or the dot at x equals 4. Now, if you're working in 2 dimensions, now you're going to have your y-axis, and what that means is that it's not just the point on the number line, it's every single point on the coordinate plane where x is equal to 4, which is going to be that vertical line right there. So if you are asked to draw the sketch of a vertical line, like draw the sketch of like x equals, it's going to be a vertical line. Now you might be saying, well, how am I supposed to know if it's just a dot on the number line or if it's a vertical line with the xy plane? And the answer to that would be context. So what's the context of the problem? Are you being asked for the axis of symmetry? That's going to be a 2 or a like you're going to be in the x and y plane. You're going to be in like 2 dimensions there. And so it would be the vertical line. If there's like no context at all, I guess pick something. Okay, so that brings us to how we would write the axis of symmetry. So this is the same absolute value function that's kind of covered by my head over there. And the question that we start off with is what is the axis of symmetry? Well, the axis of symmetry is the vertical line through the center of the graph. It is like the mirror line. So if you take a moment and take a look at the absolute value function, you can see that it has symmetry to it. So on either side of the vertex, you've got 2 rays, and they have, I guess, opposite slopes. So one of them might have a slope of 1 and one has a slope of -1 or 2 and -2. And then they head in not opposite directions, but one's going right and one's going left at the same slope. So the axis of symmetry is actually the vertical line right down the middle of the absolute value function. And the axis of symmetry will always go through the vertex. Okay, and that's just an important thing to note. So if you've, good grief, through the vertex. So if you've already found the vertex, then you have the axis of symmetry. So in this problem here, we already said that the vertex was 4, -1, and the x coordinate of the vertex was x is equal to 4. The axis of symmetry then is x equals 4. It's the vertical line that's going through the center of the absolute value. So if you need to rewind that and just hear that again, or pause the video and look at this graph a little bit more, so you can just see it better. Yeah, it's don't overthink it. Okay, it's gonna take the form x equals, and it'll be x equals whatever the x coordinate of the vertex is, because the axis of symmetry goes to the middle of the graph or the center of the graph, and the vertex is also in the middle or center of the graph. Oh, there's the example. The axis of symmetry for this graph is, do you guys want me to rewrite it? X equals 4. Okay, so that's going to bring us to a more challenging piece of content. So my intention is to kind of ease us into this. Most of you are familiar with inequality notation. That's your like less than, not that you guys can see it, like less than, greater than, and so forth. There are other ways that you can state intervals, and one of them is something called interval notation. Now, I don't know exactly on your end of course exam or your SATs which notation you might see, but by the time you get to Algebra 2, it's really fair game. You could see more than one notation. So we're going to start interval notation, and for this first unit, I'm going to give you some flexibility about which notation you would prefer to use. I'm going to incorporate some multiple choice questions and stuff to try to improve comfort level at with either form of notation. And then as we move further into the year, I will begin requiring a specific notation of you, but we'll kind of take that slowly. So here's a key idea, and that is in capital letters. Always, always, always use the x coordinates. So please, please, please write this down, highlight it, circle it, do it in a different color, okay? Always use the x coordinates. You never, ever, ever state intervals using the y coordinates. Now that has to do with the fact that we're dealing with a function. And in a function, y coordinates can repeat themselves. So if you picture an absolute value function, like it might go down, it's going to like cross all these like values, and then it's going to go up, and it's going to cross all those y values again on its way back up. But it will never, ever, ever repeat the x values. And so when we're stating intervals, we're going to use the x values, not the y values, because the y values might be confusing as to where we are on the graph, because we can reuse those. Okay, so always, 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 always the x. In interval notation, the smaller number goes on the left and the larger number goes on the right. Always. Okay, so when you're looking at this, like you'll have two numbers, or one of the numbers might be infinity. Okay, so if it goes on forever, the interval will just have an infinity or a negative infinity if it's going in the other direction. But always, 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 the smaller number is on the left and the larger number is on the right. Now, there's like a little bit of an example there where you see like, let me grab my laser pointer here. You have parentheses, smaller number, comma, larger number, parenthesis. And that's actually going to look a lot like an ordered pair, like the 0.12. Okay, in fact, the notation is going to be exactly the same. So everybody's excited to hear that. Use parentheses if the number is not included, or if it's infinity, because infinity is technically not a number. Like you can't include infinity in something because it keeps going. Use brackets if the number is included. And by a bracket, what I mean is something that looks like that. Oh, that's like a bad one, but like that. Okay. That the first one, just erase it. Looks a little, well, it was like a little narrow there. Okay, so sometimes you'll see parentheses, sometimes you'll see brackets. You use a bracket if the number is included, and you use parentheses if it's not. So I wanted to go through some examples. So there are some examples there. So the first one is like -4 and then comma 7, where the -4 is bounded by a parenthesis and the 7 is bracketed in. Okay, and then the next one is -5, 0, and they are both included in parentheses. And then the last one is 8 and infinity, and the 8 is bracketed and the infinity is not, because we never bracket the infinities. Now, notice in all of these, the smaller number is to the left. So -4 is 7, -5, 0, 8, infinity. You're always going like from left to right if you were looking at that number line. So on the next slide, I wanted to demonstrate what these look like. So these are just in one dimension in a line, okay? And we have like, we'll just start with -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Just didn't have the time or patience to do that. So what we would do if we were to graph this, the -4 is on the left. Again, it's always smallest to greatest. But the -4 is a not included, meaning it's not part of our solution or part of our set of numbers. And the way you might be familiar with that is you use an open circle. I don't really like where I put that, so let me try again. Okay, an open circle. So open circle means it's bounded there, but it's not including the boundaries. So it, like, we can get closer and closer and closer and closer and closer to the -4, but not like, it's not going to actually be the -4. Now, the 7 on the other side has a bracket, and what you might be familiar with from an earlier class is that's what's called a closed circle or a filled-in circle, and that's how it would look on the number line. So it's whether or not you're including this. So 7 is actually included. It's not 6.9, 6.99, 6.999999999, but not the 7. Like, the 7 actually is included. On the other end, we can do like -3.9, -3.999999999, but the -4, no. And then everything in between. Okay, so anything in that interval. The next one is -5, 0. So we have like -5, -4, -3, 2, -1, 0. And in this one, they are both in parentheses, which means neither of the endpoints are included, but everything in between them would be. So somebody, I hope, is saying to yourself, well, how am I supposed to know whether this is the interval from -5 to 0 or whether this is the point -5, 0? And the answer is, once again, going to be context. So like, what's the question that you're being asked? Does it make sense for the answer to be a point, or does it make sense for the answer to be an interval? That's how you're going to know. Probably like nobody really wanted to hear that. Now, the next one, we've got an 8, and then it goes off to positive infinity. Now, the 8 is bounded by a bracket, so it is included. And in this case, we just draw it going off. That was my cat. One of my cats trying to start in my video. It goes off to the right, and there's no end to it. So there's no end point on the other side. You might also be comfortable saying this as x is greater than or equal to 8. And that's the other notation. It's not like one notation is more correct or better than the other. They're just different ways of expressing that same interval. So you could say 8 to infinity, or x is greater than or equal to 8. If it wasn't included, if the 8 wasn't included, we would just say x is greater than 8. So anything greater than 8, but not 8 itself. So I wanted to go through that because when we're stating increasing, decreasing, positive, and negative, I don't know if you can hear it or not, but I have a cat that's just, he's got the zoomies running around my apartment. Okay, when you're stating the intervals where the graph is increasing or decreasing, either notation will work. So we're going to go back to this same graph, like this example graph that we've been working with, and we have increasing. So what does it mean for the graph to be increasing? Increasing is the graph rises or goes up. I don't really care what you put in there. I'm going to put rises because it'll fit a little bit better writing on my laptop. So the graph rises as you move from left to right. And then decreasing is the graph falls. That is supposed to be a cursive F, but that is a disaster. Okay, the graph falls from left to right. Now, again, when stating intervals, use only the x coordinates. Now, now that I have a graph up here, the reason it has to be only the x coordinates, if I say something like y is equal to 2, okay, so I use the y coordinate, there's actually 2 places where y is equal to 2. It's equal to 2 here, and then it's equal to 2 over here. And if I just say y is equal to 2, I don't know which of those points that you intend for me to look at, okay, if we just say y is equal to 2. But if you look at the x coordinates, if you say x is equal to 2, well, that only ever happens once. And that's true for any... What are you doing, dude? He's acting like he's Trump. He's not. He's fine. He just jumped on a cat tree. Okay, so the x coordinates are never, ever, ever going to duplicate, but the y ones do. So what I'm going to do is, and I'm going to have you guys do this on your homework and stuff, and we'll do this in class as well, is I think it's easier to highlight. So there's a lot of different ways that you can demonstrate what you know about increasing and decreasing. So for a lot of students, you have an idea of what this concept is. Like increasing means the graph is going up as you go from left to right. So as I trace the graph, and then decreasing means it's falling. So you start on the left side of the graph. Now, that arrow, don't let that arrow throw you off. All that arrow means is that the graph continues in that direction. Okay, so we're going to go over to the left side of the coordinate plane, however far left we can go. And now he's about to lock himself in a room. Okay, you go over left and then trace the graph. So I can see it is, turn my thing off, there we go. It is falling, 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 falling. And then when I get to the vertex, now it is rising, 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 rising. So the first thing I want you to do is like pick a color. What are you going to highlight it in? You can use a pencil and a pen. You can use some colored pencils. I'll have some stuff in class. Like maybe you can look around your house to just see what you got. Okay. So if I'm talking about where it is decreasing, I am talking about that interval right there. If I am talking about where it is increasing, I am talking, I didn't change my color. Yeah. I am talking about that color right there. Okay, that piece. So you got decreasing, decreasing, and then increasing. What I learned last year when I did this lesson was that the basic way you can demonstrate if you know what the words mean is by highlighting. And then the next skill is, can you appropriately write that interval using the notations that we have available? Okay. And that's like a separate skill. So you can learn, you can know the definition and struggle with the writing of it. And I want to be able to separate those. Like I want to know where, if you're having a problem, like where does the problem occur? So begin by highlighting it. Now we want to talk about like, how do we state this? So what I'm going to do here is I'm actually going to expand my highlighting to cover like the x-axis, okay? And if I look at like where it's yellow, where is this graph yellow? It is yellow starting all the way down here at negative infinity. Now, how do I know it's negative infinity? Because that keeps going to the left. It's like it's not stopping. And it's yellow, 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 and it's actually going to be yellow all the way up until I get to the 4. Okay, that's when it stops being yellow. When I get to the 4, now I am in green territory. So 4 is where it changes from yellow to green. That's where it changes from decreasing over to increasing. So there are a couple of ways you could write this, your answer to this. You could say it is decreasing when x is less than 4, and it is increasing when x is greater than 4. Okay, that's one way that you could write it. That's using inequality notation. If you were asked to use interval notation, the way it would look is this. It is decreasing from negative infinity up to 4. And then whether or not you include the 4, I have actually seen textbooks and professors do that both ways. Like some will not include the 4 in either, and some will include the 4 in both. We're going to go with not including it in either. And then where is it increasing? Well, it starts increasing at 4, and it continues increasing all the way out to positive infinity. Now, what I would like you to do in this lesson is to try your hand at both forms of notation. Just try them both. And as we go over classwork, as we go over homework, as we go over study guide, if you realize that you are doing better at one notation than the other, then that's the notation I want you to use on the test. But when it's low stakes, when it's just like, here's the classwork problem, like try to do it in both. Use that to kind of figure out how comfortable you are. And then when it's like game time, pick the one that's going to work best for you. Okay, and that brings us to positive and negative. Now, one of the biggest mistakes that I saw last year with this was confusing the definitions of increasing, decreasing, and positive, negative. So you want to make sure that you do know the difference. Increasing and decreasing has to do with like as you're traveling along the graph, are you going down the roller coaster or are you going up the roller coaster? Okay. Positive and negative has to do with whether or not it's above the x-axis. So positive is where the graph is above. This is way too small on my screen. Like above the x-axis. And negative is where the graph is below the x-axis. And I apologize for how small that is. I'm writing on my computer screen, but like the actual PowerPoint is really small on my computer screen. And there isn't like a tab that I can see. Maybe this one. I don't think I want to mess with that partway through the recording. Like there might be a way I can make it bigger, but it's like really small on my screen. So positive is above the x-axis, negative is below the x-axis. And as with increasing and decreasing, highlighting the area is going to let me know whether or not you know the vocabulary, even if the notation is a little shaky. So as before, you only use the x-axis. Okay, so I'm going to start with positive. So where is the graph positive? Where is it above the x-axis? Well, that would be here and then again over here. So I want you to note that there's actually 2 separate intervals where the graph is above the x-axis. You've got like one on the left and you have one on the right. And then where is it negative? Well, that's below the x-axis. So that is that piece right there. Again, on your homework and on your test, we're going to do this with highlight the interval. Okay, we're going to split this up, into like smaller scales. And I want to see if you know what the words mean. So positive is above, negative is below. Now, when it comes to stating this, you might be wondering, well, how am I supposed to state something that is in 2 intervals? I'm going to show you. So notice again that we do care about that x-axis. So everything that's in yellow territory, we're just going to color in like yellow territory. And then I've got some green territory, and I didn't change the color over. There we go. Okay. So what I hope you can see is that our yellow territory starts down here at the left, and it stops when I get to the 3. Okay, it stops when I get to the 3, and then it picks up again at the 5 and goes on for forever. My green territory or my negative territory is this little piece in between the 3 and the 5. So for positive, I have no idea where there's enough space to do this. So for positive, you could state it this way. You could say it is positive when x is less than 3 or x is greater than 5. Again, like here it is. Here's the 3. If I go less than 3 or if I go greater than 5. If now notice that there's also like you have to say that in 2 different steps. Like because a number isn't less than 3 and also greater than 5. So if you say x is less than 3 and x is less than 5 or greater than 5, I know what you mean, but it is the wrong math word. So it could be one or the other, but a point can't be in both places at the same time. If you wanted to use interval notation, it would look like this. It would say it starts at negative infinity and goes to the 3, and then it picks up again at the 5 and it goes to infinity, and then you put that symbol right in between. It looks like a U, and that is for union. It means like both sets, both places will work. If it's to the left or if it's to the right, both of them work. So it's like I think like if I don't want to come up with an example because as I mentioned at the beginning, I'm really tired. So okay. Now for negative, you could say this. You could say 3 is less than x is less than 5. That's what's called a compound inequality. You're basically saying 3 is greater than x is greater than the 3, and at the same time, x is less than the 5. But most of the time, we'll just say something like x is between the 3 and the 5. 3 is less than x, and x is less than 5. If you wanted to say that in interval notation, it would be the interval from 3 to 5, but not including either of them. And again, with that notation, for now, use both. Use both sets of notation and just see which one you're getting better luck with in terms of getting problems right or that you feel more comfortable with. And then come test day, pick the notation that is best for you. Okay. And then as we move in like further through the year, and we're going to come back and revisit this in a future lesson, I'll start to get a little bit pickier about which notation you are using. All right. Last one is end behavior. Oh, and that is poorly placed for this video. So end behavior. There we go. End behavior. Basically, you need to state which direction the graph points on the left and the right. So when we say end, we mean the left or the right. Again, keeping it with those x coordinates, left and right, left and right, left and right. Behavior, we mean, is it pointing up or is it pointing down? Which way is it pointing? You need to state which end, so the side that you're on, and also the direction that it is pointing. For absolute value, they're going to be the same. Okay, so because of absolute value, they're either both going to point up or they're both going to point down. Not for every function that we ever look at, though. So for this one, if I look at the left side, I can see that the graph is pointing up. So you could just write left, up. And then you come over here to the right side and you see that the right is pointing up. You can sometimes get away with saying both sides point up. Like that is fair game. But typically you'll say like which side and then which direction it is pointing. Don't overthink it. You're gonna and do say them both. I've gotten some strange answers for end behavior. So you have to state the end, left to right, and is it pointing up or is it pointing down? Last little piece of content for this lesson is this. There are some other notations that you can use for end behavior. I actually don't like them. So from the perspective of somebody that has to grade your work, it is easier for me to see left, right, up, down. But other notation is more mathematically comprehensive, and it is fair game for what you might see. So you might see for this something that looks like so. I need to change that back over to the pen. As X, and then you'll see an arrow. And then you'll see like either infinity or negative infinity. The way that you read this out loud, it says as X approaches negative infinity. So let's like break that down. Here's X. See it there? As it approaches means you're moving, and the direction you're moving is towards negative infinity, which is going to be this way. That is a fancy schmancy way of saying left. You're going left on the graph. And then you might see as X approaches infinity or negative infinity, Y is going up. Well, which direction is that? That is infinity. And that did not come out right. It should be like Y, and then you'll see an arrow, and it says infinity. And then you might do the other direction as X approaches infinity. So what does that mean? Here's my X-axis. And if we're going towards infinity, positive infinity, that is a fancy math way of saying to the right. And as I go to the right, where's my graph going? My graph was going up. You might also see f of x instead of y. Okay, so you'll see as x does whatever. As x approaches infinity, f of x approaches negative infinity. So that's the other notation that you might see. I think you can see why if I'm grading it, it's like, it's just more annoying. It's like easier to say left, up, right, up. This is easier to grade. But again, that's not mathematically super sound. So this is a more technical way of saying it, and you should know it and be able to execute it. So there it is. Now for this first unit of the year, I am not going to be picky about the notation. I want you to focus on understanding the concept. So that pretty much wraps up this lesson. There should be notes and homework posted, or there will be notes and homework posted shortly. As always, let me know if you have any questions at all.